Welcome to Ask and Learn.
In this problem, we are looking at a cylinder mounted on an axle. It's with a 3 Newton force applied tangentially to its surface. Its radius is 0.14 meters, and after it starts spinning from the force, the angular displacement is measured and graphed against t squared, and it makes a straight line with a slope of 16 radians per second squared. So given this information, we are supposed to find the moment of inertia of this cylinder, and using our two torque equations, we can figure that out. So seeing that these are both equal to torque, we can set them equal to each other. Moment of inertia times alpha equals r f sine phi, and then isolate the moment of inertia, r f sine phi over alpha. Okay, and now we have everything on top. All we need to find is alpha, which we can do using this information about the graph that's presented to us. So this is the slope of a graph of phi versus t squared. So if we plug in this slope here, we know, and given that it's a linear graph, we know that this graph is going to look something like phi equals b plus 16t squared. And now just looking at this, we can see that it bears a striking similarity to our equation of motion. Theta is equal to theta naught plus v naught t plus, not v actually, omega naught t plus alpha naught t squared. And given that it's starting at rest, this is going to be 0. So we can see the similarity here. I forgot the 1/2. Sorry about that. So we can see the similarity here and see that this 16 is going to go where this is. So 16 must be equal to 1/2 alpha, or alpha must be equal to 32. But if just saying that these things look similar isn't good enough for you, I can just do the math and show you that this is going to be the case either way we do it. So once again, we know that this is what the equation is going to look like. Theta equals b plus 16t squared. And we know that alpha is equal to the second derivative of theta with respect to time. So all we need to do is take the second derivative of this, take the first derivative first, leave 1 here. So the first derivative of this is going to be 0, plus bring down the 2, so this will be 32t. And so now take the second derivative, the 0 is going to stay 0, and then this derivative will just remove the t, and we will get alpha is equal to 32 radians per second squared. And now all we need to do is plug in our numbers. Moment of inertia is equal to r, 0.14, times f, 3, times sine of phi. It's tangential to the surface, which means it's going to make a right angle with the radius, and the sine of a right angle is of course 1, and that will all be over 32, which will give us a final moment of inertia of 0.131 kilogram meters squared.